Welcome back, geometers. That's the real word for it. So today we get our first day looking at this. We're going to take a look at this Explore section for 1.1. We are looking at the foundations of geometry. Anybody have any questions for me?
What is your favorite day of the year?
Henning asks, what is my favorite day of the entire year? I've thought about this a lot. It's in the summer. I like the nice weather. Do you guys know the numbers of the months? If I say the 6th month, do you know what that is? Okay, my very favorite is 6, 7. All right, so, yep, got him. So check it out. But they can't see me. I didn't know that part. No cap. All right, so here we are. Looking at this. You guys remember your numbers? Okay, do me a favor. First 2 weeks. I'm just going to call you numbers. And really all year I might call you numbers, but I'll know your names. When I call your number, please tell me your name before you answer the rest of the question so I can get it memorized. Sweet. I almost have half of you. Cool. There are 21 of you here. What numbers don't have phone in them?
1, 15, and 19.
Okay.
25 and 6.
Akis, what's your number? So what are the 2 numbers that are empty that aren't yours?
5, 6, 15.
Wait, there's 3 empty? There's 4 empty.
4.
Ooh, I better actually take attendance because I have a different number. Well, sorry. I'm stopping at 21.
There's 5 empty.
Really? I did not look closely enough. All right, let me do attendance for real then. I'll pause this. We'll do this. We'll do this. If I call a blank, let me know, and I'll pick somebody else. Cool. So check it out. Number 21. There's no right or wrong. How would you give me one way to possibly find the distance between these? I don't know who you are, 21. Okay, I do. No, you're not. Hit it. Give me a way that we could possibly find the distance between those. Anybody else come up with that same idea? You literally count it. Okay. Did you count these? Anybody count the distance here?
Yes.
Yeah, totally valid. So A, and I'm not going to be crazy unless it's really specifically told. You're going to see me write the laziest, least formal sentences, maybe not even qualifying as sentences because I don't write a lot. Anyway, you can count them. It seems like a silly answer, but absolutely. 1, 2, 3, 4, 5, 6, 7, and 8. It's 8. Yeah, I'm good with that. Cool. Is that reasonable? Is that like crazy hard to do? No. It's reasonable for a problem like this. Is there another way I could do it? Number 14.
Add the distances from 0.
Ooh, you could add the distances from 0, and he even finished it further. If I take any number and I think of it distance from 0 on a number line, it'll never come up negative. It means negative numbers turn to positive, and positive numbers stay positive. I heard him say the other word, but he's talking about a math idea that you guys have seen. Absolute value. So, second approach, maybe, and these are both fantastic. You said, in different words, add absolute value. Now, you'll see pretty quick, there are some shorthands that I use that are Holloway shorthands. There are some shorthands that I use that are formally accepted in the world of mathematics. This, I would say, kind of flirts the level between both of them. What do you think ABVAL stands for? Absolute value, which is just the distance from 0. So if we try this problem with that context instead, this number is how far from 0?
3.
Let's see, there's 1, 2, 3. I think it's 3. And this one, if you can't see, it's 5. And don't forget, Relly, there's a screen right there too.
Oh.
And this one is 5 away, right? We could just add these. What do we get?
8.
Hey, it's the same answer. Is there another way you could do it? I would say it's almost the exact same way. It just looks a little different. One more time? You said add, no, it wasn't nothing. You said add the 2, but I didn't catch it.
Well, 6 is 5, 6 is -3.
So it'd be weird if you just try to do 5 plus -3. You're going to get the wrong answer, right? But we're super close. Michelle, I think you had another one. Subtracting. Give me another word for subtract. Like, the answer to a subtraction is the difference. If we're looking for the difference between two numbers, that is the same as distance for this context. Okay. If we subtract these, we need the absolute value though, because if we do it in the wrong order, we want to make sure that we're right. So I need your guys' help. I don't know how Miss Jarvis taught this, but if I do one direction, I might have the subtraction absolute value instead. So if I do the absolute value of 5 minus, what's the other number?
3.
Try again.
-3.
Why did I make you say it again? That's redundant.
Because it's a negative and a minus sign of 2 different things.
Minus and negative does, so I kind of. I don't know that I really agree with you. Computers would agree with you. But subtracting and a negative, they're representing the same idea. What happens when I subtract a negative?
Positive.
Why?
Because it's the negative, the opposite of an opposite, so it's gonna be
Okay. So what happens here? What do I do?
big add.
You guys used to do it how? Would you do this?
Yeah.
Okay. I have a different device, but it's the same thing. I say minus a negative becomes plus a positive. I like the alliteration. Machine Gun Kelly and me go way back. So here we are. What do we get when we do that? 5 plus 3 is 8, and the absolute value of 8 is 8. What if we had, by total happenstance, gone the other way? Negative 3 minus 5, and take its absolute value.
8.
Negative 8, and the absolute value is?
8.
Oh my gosh. Every single one of these options came up as 8. Are they all equally valid?
Yes.
Okay. I think there's one that will fail. Maybe not in this example, and I wouldn't say fail, but anybody have like endless time? Yeah, like, do you have a limited amount of time to do stuff? In, like, even just to be alive, probably?
Yeah.
I think so. I haven't died yet, to my knowledge, so we'll see. Or this is my heaven, which makes this that much sweeter. I don't know. I like my job. That's okay. All right. Counting works, right? How many of you guys would go with counting if that was your option? Okay, I'm going to make a new number line. Nope, don't draw this. I don't care if they're, like, just imagine that they're so close together that these are the lines. Now, you can't physically count the ticks, but if it were drawn really well, you could. So the good news is all you have to do is count right here from negative 7, I don't know. Who feels confident reading this number?
That's 7,001,359,200.
So negative 7
Oh, no, negative
billion. Okay? And I want you guys to count the ticks, because we're just doing the same thing, right? It's just a different number line. I want you to count this number. Are you going to count the ticks?
No.
Follow up. Do you know what that number I just wrote on the board represents? Like, not by name, but do you know what that 3.7 times 10 to the 12 is? It's scientific notation. That is 12 zeros. That's a billion as well. Trillion? Trillion. Okay. Are you going to count those ticks? So I'm going to ask that same question. Given just in general these types of problems, is counting always going to be really the best way to do it?
No.
Will it work?
Yes.
Could you, given enough, like, do you have enough time in your life that if I said start right now, could you count from those to those?
No.
Not a chance. How much time is a million seconds? Have you been alive for a million seconds? Yep, I think it's like 11 days. We can check that here in a second. I think it's 11 days. How long is a billion seconds?
Like 35 years.
It's like 33 or 31 years. Like, yeah, it's huge. Yeah.
1 billion.
If you counted one time a second, a billion would take you 31 years to count. It's crazy. You can't actually count that high. Nobody has time. But we're looking at this. We are introducing and kind of playing around with this first idea of how do we measure stuff. We're measuring a specific object in geometry right now. You guys have seen a lot of these geometry terms throughout your math curriculum, right? 7th and 8th grade, I think you hit geometry pretty hard. If you took Algebra 1 last year, you probably did almost no geometry, and that's totally okay. Okay, as we look at this, I'm going to say we'll start our first section here. So every day we're going to look at this. We're going to build on this today. I'm not going to say anything else about this right now, except for the fact that I bet we see this stuff show up again in this lesson. Cool. Before we move on, 5 says I'm okay with all of those methods and I'm comfortable with it. You don't have to broadcast it to everybody. You can put it here. So 5 says, yep, I got this. I could do a problem. If you gave me an example similar, I could do one the same. 0 says, I don't know what the hell's going on. Anywhere in between is fine with me. Where would you put yourself personally? Okay. I might do thumbs up and thumbs down from time to time, be honest with it. If everybody gives me thumbs down, that's an issue, right? I did something poorly and I need to retry it. If everybody gives me thumbs up, it's the key to move on. Cool. So these ideas will show back up. Let's get rolling with our first main topic today. So in chapter 1, section 1, we're still in our notes and we'll start modeling this. We are going to be talking first and making sure that we are in agreement about what it is exactly that we're talking about. So we're going to see a few examples of some geometric figures. And they're going to be figures that I think you have seen before and you'll be comfortable with, but we'll check. I'm going to write a few words here, and I'm going to let you guys talk for a minute before we tie them all together. So within these geometric figures, we have some terms that are kind of weird to define, which just means if we wanted a definition to say, oh, this is exactly what it is, it's a challenge to do so. So quick check. I'm going to write a list of like 6 words, and I'm going to leave a little bit of space so that we can give definitions as we build them. So we'll have the term and what it is, and then we'll also have a short definition, which the word definition is kind of long, right? Okay, I make up my own fake contractions. So like can't is cannot, but check it out. DEF apostrophe N, my apostrophe here is for the initiate part of this. Definition. Okay. And then the way that we denote or notate. How do we physically write this down? Because turns out I'm kind of a crazy guy about that. When we write stuff, we have to be really clear with what we're writing. If you've ever had a teacher yell at you about units or anything like that, you've seen it. But here we go. As we get through these, first term, and I'm just going to ask for a thumbs up or down if you think that you know what it is and you could explain it. And then we'll break out and we'll let you guys talk about them. Okay, first one, a point. And anytime that I have a vocab word, I write it in all caps. Who in here knows what a point is? Reasonable, not a lot of confidence in here. For real, only 3 of you think you know what a point is?
Oh, a point?
A point? Like in math, a point? I mean, you can also point to something. No, like if I said plot the point, whatever. Okay, there we go. So now, let's hold on. I'm going to let you guys talk. Okay, everybody seems to know what a point is. Most everybody. All right, let's get another crazy one. That didn't seem hard. A line. Who in here knows what a line is? Okay, sure, we'll see. This one, we're not talking Raven, especially anymore, but how about a plane? Not the aeronautical type. You might be thinking coordinate or Cartesian, where you graph stuff, right? Have you guys graphed something? Whether it be a line or a curve, it doesn't matter. If you've graphed it on that X with the grid, that's a plane. Okay, I want you to try to define that more than what I did. Okay, nothing too crazy yet, right? All right, we have 3 more, and then we'll give it like 3-ish minutes. How about a ray? A ray. Maybe, maybe not. I think of the sun when I think of that. Right away, that's where my head goes. All right, couple more of these bad boys. How about a segment? You think you know what a segment is? A line segment, yeah. We'll see. And then one more. An angle. Y'all know what an angle is? Yeah. Do you? All right, here's my challenge for you. With your neighbors, groups of, I don't know, 2 to 4, depending on who you're working with. For each of these, I want you to pick one person in your group to jot down really, really concise, which just means with as few words as possible. I do not want pretty, flowery paragraphs. I want, if you can do it in 3 words, do it in 3 words. We caveman talk here. I'm cool with it. Or cave person if you'd rather, sorry. Okay, we're going to go 3 minutes. With your neighbors, pick one person to jot these down on the side of their page. We'll come together and see if we really do know and can say what these things are. 3 minutes. I want to hear you guys talking loudly about these things. You're coming up with your own definitions. Okay, 3 minutes. What do you have written down, or your partner? It could be an ordered pair, right? Now, if you're on the Cartesian plane, that's an example of how we write a point. I'm good with that. If it's brown, don't write it down today. We'll switch colors every day. So this is all just me writing extra stuff, okay? This is a point, I think. Do you guys agree?
Yeah.
Is this a point?
Yeah. Oh, no. Wait.
This is a point in 2D space. This is a point in 3D space. I can't envision this one, but do you think that this probably also represents a point
Yeah.
in 4D space, right? Like, I can't even imagine what that looks like, but that's okay. I don't need to be able to imagine it. The mathematics exists. Okay, as we look at this, you've given me fantastic examples of points, but you haven't really told me what a point is. Okay, a really easy answer that is natural to have and more than one group had. How many of you guys have a dot on your page? Something, dot, a mark, like something similar to that. Okay, I have an issue with that. Is the scale important when you're graphing stuff or drawing stuff? If you want it to be accurate, your scale, like how big you draw stuff, is important. Okay, so I'm going to have you guys all, and we're going to play the trust game. I'm going to open up Desmos, and I want you guys to close your eyes for like 5 seconds once I have this open. Yeah, I had to give you that. Okay, everybody close your eyes right now. Okay, everybody, you can open your eyes. Is there a point up here on the board?
Yeah.
Okay, can you tell me what that point is? It looks like 4, 3, right? Okay, if I zoom out, does it look more like 4 and 3? No. Really? Yeah. Or the same amount, at least?
Yeah.
Okay, I'm going to start zooming in on this. Does it still look like 4, 3?
No. Yeah.
If the numbers show up when I did that?
I can't see the 4, but I can still see the 3.
So you can't see it, but I'm like, it should hit right on that corner, right? Right on that hatch, that where they cross. So if I keep zooming in and in and in and in, it looks great still. Here's the issue that I have, and I really hope that I didn't go too far. That's not the 0.43. It's the 0.4.00001 and 3.00001. Is the way that you draw this point really going to represent what it is? If I went out to 3.000 and I let it go for like 50 zeros and a 1, if I zoom in far enough, will I still be able to tell it's not quite the right number? Like now as I'm getting closer, can you tell it's getting off? Oh gosh, it's not on that hash. Okay, there's an issue. The dot on your page, and this is almost a philosophy argument, which makes sense because we're math and philosophy. As we go through this, the dot that you draw on your page, is it the point or is it a representation of the point? It's just a representation of it. Because a real point, you can never draw. Like, you just can't do it. When we look at this, what that means is we get our first weird definition out of this. For our purposes, we draw points on paper. We identify them on paper with the understanding that it's just representing a location. So this is all it is. A location, this is it. Now, if we want to be more specific, we can say in space. For this class, 99% of the time will be in two-dimensional space, flat page. But there's certainly a location right here at the tip of my finger that's in three-dimensional space. There's stuff that I can't even fathom that's in four-dimensional space. Okay. Because it is only a single location in space, there's a weird outcome of this. Furthermore, beyond this, it means that there is no shape or size. A point has no size. It is a single location. And again, I just want to stress, the points that you draw on your page, the representations, they might be big, right? If I wanted to plot a point on this graph and I had done it like this instead, I just have to copy paste this. If I wanted a specific point on any plane or Cartesian coordinate system, whatever it is we're looking at, if I drew my point like this, would it annoy any of you guys? So let's say I wanted the point right here where those meet. Okay, I could do it well, I think, probably. I don't know why I can't see how big the marker is. Weird. This point right here. Is that a good way to draw that point?
No.
It's terrible and I hate it, but is it wrong? Is it any more wrong than the other? No, it's still indicating that, hey, my location is somewhere inside of that shading, right? Even if I make it small. Is that perfectly where that point is? No, my actual location is underneath that dot that I've drawn. That's the distinction that I want to make sure that we have. Okay, it's weird that we can talk about it without having a real definition because there is no real true definition, even though we tried to write one. These are called undefined terms, and we're going to see weird little things about all of these. If I wanted to label this point, how would I do it? How do you name a point? You can do it with ordered pair. Is there another way? What if I don't know the numbers and I just want to be able to say, hey, that point without knowing what its numbers are?
Point and number.
I could make up numbers if I needed to. Alternatively, what we'll default to more than just making, like we will make them up, but we don't care about numbers in here for a lot of the time. What we care more about is being able to identify it. To write down a point, it is a single capital letter. Ooh, if I have the wrong capital, tell me, but I'm not going to change it. So I'm also going to do a quick example of these. Here is a point, a representation, and if I wanted to name this B, have I done it correctly?
No.
No. Why?
It has to be capital.
Oh, my capital. Okay, it can be A, B, C. I don't care what letter you pick. I wouldn't choose O. But this is how we write down points. If you give me lowercase points, I bet I take off partial credit at least. Like, I'm crazy about it, but geometers are. Cool with that one. All right, what'd you guys come up with for the definition? What's a line? Number 5. Jonah. Oh, man. I'm not going to beat him. I don't want to answer this question. This is a fun one. Number 9. I don't know who it is. Number 9 is Klein?
Yeah.
Feeling fine. What's a line?
Line is
All right. So we've already shown the trap, right? It's hard. Anybody want to volunteer another one before I randomly call on a different group? Could you identify a line?
yeah.
Yeah.
Is this a line?
Yeah.
Mm-mm. Mm-mm. Ooh, that straight part of it has to happen. Okay, that's a curve, which fundamentally are different. Lines are straight, curves are straight or bent. It's a classification. We'll get working with it. So I know it has to be straight. If I draw a line, and assuming that it is really and truly a line, does this look more like a line?
Yeah.
Almost. Why does it stop? How far does the line go?
Forever.
Which way?
Both ways.
Okay, now I think I'm comfortable saying that we have a line in front of us. How many points make up a line?
Infinite.
I need 2 to name it, at least, right? Like, I'll always name it with 2, and we'll talk about that. So, like, let's say I have point A and B. Do I have a line that runs through A and B?
Yeah.
I didn't label them, but are there points that exist between A and B?
Yes.
So, let's hypothetically say I pick right here, it's C, just for fun. Is there a point between A and C?
Yeah.
It'd be D. How far would I have to keep going to do this? Would I ever stop?
No.
No, there's infinitely many points in a straight arrangement. Like, that's all that this is. They go on forever. There's infinitely many points. How big is a point?
It's a location.
So does it have any size?
No.
Points have no size. If a line is made of infinitely many points, does a line have any size?
No.
No, it can't if what it's made of doesn't have any size. Right, Klein? Cool. So check it out. We will say that a line, by definition, is an infinite. Is there a symbol for infinity or infinite? Okay, anybody know what the actual name of this thing is other than a sideways 8? You will not be tested on this. This is just a random fun fact. It's called a lemniscate. That's the name of that shape, a lemniscate. Okay, a line is an infinite number of points. Extending forever in a straight path. If you can make that a caveman or cave person definition and write it with 4 words and it makes sense to you in your notes, I'm good with it. Cool. A line is just an infinite number of points extending forever in a straight path. There is no height, there is no width, because the things that it's made of have no height and have no width. Nothing. It's just infinitely going. Now, for a quick naming thing, there are 2 routes that we can possibly take. So we'll have a couple examples. We have two options though. You can choose when you name a line, and I suppose I'll just write it without the bullet. 2 points on the line. There's one way that we can do it with this symbol above. It's just an arrow going both directions. One way that we can write down a line. My preferred way, however, is less writing than that. I like a single italic lowercase. That's it. One or single lowercase italic. Okay. Instead of doing an example for each, I'm gonna not do examples right now. When we get all 6 of these locked in, we'll have a single picture and we'll identify all the different parts of it. Cool. All right. Well, I've probably just destroyed your confidence with answering these questions today. Who has a fun wrong answer about a plane? What is a plane? Ooh, 2 lines that overlap. I have a plane?
No.
Oh.
Wait. Like a grid? I don't know. Like what you said?
I mean, I could make this gritty. I don't know how to do it. Otherwise, I would have. Huh.
Wait, never mind.
I like it. You're not super far off. I agree with. Like, I'm being obnoxious with it.
Flat surface.
Oh, it's flat.
Yeah.
It is so flat. Okay, check it out. Plane, infinitely many points. That form a flat surface. How far does a plane go?
Forever.
Forever in all 4 directions along that flat surface. Going forever. Now, I would usually say extending to infinity, but going forever feels a little bit shorter to write. Okay. To define a plane, and I'm going to let you guys, when I start talking as you're still writing your definition stuff, call me out because I'm going to do it all year long. Okay. We've seen a few different little examples. For a point, it takes a single location in space in a single capital letter. To define a line, how many points do you need? Even though there's a lot of them, you only need truly two. What if you wanted to define a flat surface?
3?
Does 2 do it?
4?
Why doesn't 2 do it?
Because that's just a line. There's no way to find the other line.
Yeah, check it out. If I only have a straight, like 2 points, here they are. I can set these on these 2 points, right? Now, this plane is a flat surface. I can imagine it's bigger than it is and extends out that way and this way and that way. But on this hand, could I rotate it down here and now it's elsewhere? Like I can spin it, right? And it can move around itself. I can find different lines that cross through both of them and now I have a different flat surface. 2 points doesn't do it. We don't need 4, 3 points. We need 3 points on a line, but they have to be special. So, as we look at this, to name a plane, there's a super important word that we need that I don't want to dig too crazy into definition stuff, but we can name this one of 2 ways. 3, if you see co in front of a word, what does that mean? So, coordinate. If you coordinate with somebody, you're doing it together, right? Everybody okay with co typically means that it's together with something. Okay. What does linear mean?
Straight.
A line, because its line is in there. Linear just means straight. So if I said points were collinear, together on a line, does that seem reasonable?
Yeah.
Co together, linear, line, they're on a line together. So for example, again, you don't have to do the brown one, but if I have this line, I could name it with these 2 points, but are these 3 points on the same straight path? So they're collinear, because I can draw a single line through all 3 of them. If I put this point, is it collinear with the others?
No.
So, without having to write down that word in definition, we'll say 3 non-collinear points. You have to take 3 points, they just can't be on the same line. Okay. Alternatively, if you don't want to have to write it down with those 3 points, you can use a single capital italic. Now, I typically use cursive because I don't really know how to write italic. But we have it. Okay. Everybody feeling okay so far? Okay, I promise that not every day is this boring once we actually start to get doing problems, but we have to lay the groundwork first. Okay, where does the light that's outside originate?
Sun.
Okay, when it leaves the sun, how many directions does it go? So imagine, do you know what carries light around our universe? It's a photon. Nice. Okay, imagine one little particle of light leaving the sun. It goes in a straight path, and eventually it'll strike the Earth, right? If it didn't hit the Earth or any planet, how far would it keep going that direction? Forever. It's going to go that direction forever. Does it go that direction at all?
No.
No, light leaves the sun and goes whatever way it's shot out at, and it goes forever. Okay, that is not quite a line because lines go forever both ways. It's not a, we didn't talk about the other one. It's not a line though. It starts here and goes that way forever. It's like a ray of light. A ray.
Like an arrow.
A ray. Okay, so yeah, it's essentially like an arrow. Now, we'll add a little bit because I meant to give examples without pictures here, but let's check it out. We'll say this is a portion of a line with one endpoint. There's one place where it ends or begins, but we call them endpoints, with one endpoint. Okay, we're going to try something. I would like to be a little less wordy when we're talking about the notation. So if I need to write more words, I can. But check it out. Since it's a part of a line, I could just use 2 points and indicate where we start. If I wanted AB right now as a ray, it's not quite there. To be a ray, we need to indicate by notation. We can use starting point and any other point on the ray. So AB, where do you think it starts? At A. Is ray BA the same thing?
No.
It's the exact opposite direction. Okay, you can use 2 points like this, just 2 of them. Since capital letters are points, we have it with this one directional arrow, always to the right. This is the way we name them. Cool. Okay, right here, I should have done it. I'm going to sneak one in. If I want to take AB and make it a line, anything change about it? Is this, tell me it's a line you think? No, what does it need?
Arrows.
If you give me AB without the mark above it, I won't give you full points. Like, I just can't because they mean different things. Might seem like I'm being nitpicky and maybe a little bit, but every geometer ever will do this. Okay, segment. I think you can probably get this one. What's the difference between a line and a segment?
Segment is not
Not infinite. Well, ray wasn't infinite. Well, kind of. So it's when you see that word, it's called finite. It's a portion of a line that starts and stops at a particular point. Has it 2 endpoints. Easy. Part of a line with 2 endpoints. Okay, tomorrow at the start of class, we won't do the warm-up tomorrow since we're going to start a new section. We'll jump in, we'll define angle, and then I'll have a picture up for us all to talk about. Quick question with stuff. And all I'm going to talk as you guys quietly get your phones and stuff. Class is over. Wait, it's Thursday.
Yeah.
Class is over, okay. All right, just kidding. You guys go start getting your phones. I'm going to keep talking at you, though. When we have a lot of pictures and stuff, do you want handouts or do you want time to draw the picture? Oh, we're split. Okay. How about handouts? And if you have notes in your notebook, I'll give you a folder as well. Cool. All right. Agreed. All right, later Raiders, video. If you're in the Google class.